Hello everyone. In this video, I want to show you how to make flat and Phillips head screwdrivers, the head part of them. And the reason is I just was working to make these ready for my lecture tomorrow in class, in my CAD class. And I saw that actually, although they look not very complicated, but they might have some interesting features that I want to talk about. And then these letters that you see on them, STPH2 or SL6 or something, what's the meaning of that? So I want to just briefly, not really professionally, tell you about the meaning of these letters. So if you are dealing with any of them, you have an idea of what they are. So for the flathead, let me talk about the dimensions. So this is a flathead, right? So basically there is only a small rectangle, as you can see, narrow rectangle here, and there is this basically circular cross section, and the head is connecting them together, so it looks like a loft to us. And the size for it is, for instance, or the letters on it says S2 SL6. So what does that mean? So this SL means slotted, which is another name for flat head screw or screwdriver. So that means just one single rectangle here. S2 is the name of the steel. So the steel that is used here is called S2, okay? And 6 is the width of this head. So this dimension here, from top to bottom or left to right, that guy is 6 mil. So it can be used to open up a screw which the slot of it is only 6 mil wide. Okay, so that is S2SL6, and it's quite a bit clear. Like, for instance, if you look at these pictures, you can also see that, right? So this is a head size 3, SL3, SL4, 4.5, 5, 5.5, 6, and you see as you go from left to right, it is getting wider and wider. So this is what this is, a slotted or flathead screwdriver. On the other hand, for a Phillips, which has basically a cross at the tip, and it's very easily distinguishable from a flat one. The only difference is here says S2PH2. Again, S2 is the material, and PH means Phillips, and 2 is the dimension. Now, 2 here is not necessarily, for instance, the width of this guy from left to right. So if I want to show you that, okay, so the dimensions for a Phillips is a little bit not completely linear as you expect. For instance, if I say I have a PH2, right? My screwdriver is PH2. You might say, well, the size of this head is 2 mil. Not exactly. It's actually 2.29 mil. Or if it's PH3, this is 3.81. And what kind of screw could you use it to open or close, right? To fasten or unfasten. So PH3 is used for M6 and M7 screws. M3.5 to 5 use PH2, 2.5 to 3 PH1, and then zeros and 2 and 3 zeros are used for smaller screws. So clearly, as we move on from smaller numbers on these PHs to bigger numbers, you are also able to open up bigger or smaller screws as well. But just letting you know that this number that you see here and the actual dimensions are not exactly the same. So this is regarding the letters that you see on them. Now, how do we make them? So let me show you. So for a flat one, as you just expected, the first part of it is simply a loft. So I have a circular cross section and I have a narrow rectangle on 2 offset planes, and all I need to do is to connect them with the loft. The only important thing is to make sure that these 2 points are not basically, if this point, for instance, comes here, then you're going to get a twist. So make sure these points are right in front of each other, as you can see it is, and that gives you the first part of it. The second part are those cuts that you see. These cuts, right? This one here. So this is just such that you remove, let me show you from the side. So you remove this portion of the material, compare it with this side that doesn't have it right now because I removed the mirror. right? So this is for the head to easily be inserted into the head of the screw, okay? So we remove some part of the material. And clearly, as you can expect here, it's basically a cut extrude. That's all it is. So it's a cut extrude, and the profile for it is something like this, okay? So that's all you need. It's basically this arc here and two lines. And if you want to get it exactly as nice as this, so that this basically surface, the end of it, if it looks like an arc or something, the end of the arc comes and reaches the end of this rectangular surface here, right, like this, then you need to make sure in this sketch, this arc is tangent to this vertical line, okay? So you see here I have a tangency. If there's tangency is not there and here it's not tangent, those arcs will not get to each other. Let me show you. So here I get rid of the tangency and I make it non-tangent. See what happens. Look. You see that? So now there is this gap between them, and the end of this arc right here and the end of the rectangle surface, they do not reach each other. So make sure that you definitely have that tangency condition, so you get this, let's see, okay, you get the proper cut. Okay, seems like no, it's good. Okay, so now that I got that, I can go ahead and mirror this. Let's go ahead and do that. Let me update this. Let's make sure that this sketch is right. I guess the tangency. Let me do it one more time just to be safe. Okay. There we go. Right, and then of course you're gonna have some extra extrusion here for the shaft. Then you have the hexagonal part, right? So here, look, there we go. And then you're gonna have a cut revolve, which is gonna make this surface for you. It is gonna make this surface for you, and it is gonna make this surface for you. And finally, you have your final cut extrude, which is basically these leathers. Okay, so this is how you make a flathead, right? Which is what I just made for you. Of course, I just went through it, but the goal is to make this video short. So this is basically what you made, the flat. Now, of course, if you want to make it very accurate, you need to make sure what are the dimensions for SL6. So here my dimensions are not 100% accurate, okay? They're kind of a little bit arbitrary. But if you want the exact SL6, you have to go and find the drawing for SL6 and make sure this is exactly the dimensions or SL6. In this case, it's not SL6. I just put some letters on it for demonstration. The other one that is the Phillips, the process is the same. So here, to make it a little bit different from the last time, I have the profile of the head. So I made this profile here, right? And once I have this revolve part, which is this, the only really interesting part is this cut in the head, this guy. So how would you make one of these, right? And then once you do a circular pattern with 4 instances, you're gonna get the Phillips head. So the only thing is to do this, and this one, the best way to do it is a cut sweep. So the way that I did it, I have this sketch, which if you can see, it's a square basically rotated 45 degree and offset from the origin. So if you look at this, you clearly can see that I have offset from the origin. These offsets are these numbers that, again, I arbitrarily provided. These are not 100% accurate. And then I provided a fillet here at the corner. Now, if this fillet is too small, feel free to make it, I don't know, a little bit bigger. So make sure that it has a little bit fillet, right? And there we go, you see? So that is my sketch. And then this sketch has to go along a guide curve where it is a line at angle. So if you look at this line from the side view, let me show you. If I show you from this direction, this is my guide. You can use a line or you can use a curve. In this case, I use the curve. As you can see, that line is just a construction element. This curve is really what I want that rotated square to move along. But if you open up this sketch, this is my sketch, right? So this is my line, and then I made sure that this curve starts inside or within or close to that original sketch. It doesn't need to be exactly on it. This endpoint is not like loft. It doesn't need to be on the original sketch. Originally, when this radius was smaller, it was inside of it. Now it's outside of it. Both of them are fine. And then I provided some number. Again, this is not fully defined. It's just for the sake of demonstration. And this is what I have. You can use this line, but it's not going to be as realistic as when you do it with a curve like this. This is much more, much closer to the ones that you see in real life. These all have this kind of curvature with them. And then all you need is to do a circular pattern about the axis of the shaft, which you can see here, right? And then once you have that, or you can use the surface as your reference, then I added again the hexagonal part, I added the cut revolve, and I cut the specification letters, okay? And now clearly you see that this part is the crosshead, which is the specific thing to a Phillips head. So there we go. This is your Phillips head, and that was your flathead. So for the flathead, I use a loft and a cut extrude basically. And for a Phillips, I used a cut sweep. This is the main thing, revolve and cut sweep. But again, there are other ways to do it. And some of the ones that you see in reality, they have some extra feature here. Okay, so that needs some extra operation to do in CAD to make it. So some of them have something here in the middle, a little bit extra feature. So this is like a simple version of it. I just wanted to share how to make these two simple things that look very simple, but not really simple if you haven't done them in the past. So hopefully now you know how to make these two heads in SolidWorks, and thank you for your attention. I'll see you in the next video. Thank you.